Myself Vinod. Today I would like to discuss on something called electric dipole. What's that? Electric dipole. That's what I am writing here. Electric dipole. Right. So what is the meaning of dipole? Electric dipole. So for that, let me consider the two charges. Say this is minus q and here one more charge plus q. And what is the observation you can see here is the two charges are magnitude wise same. Magnitude wise the two charges are same, but the nature of this charge is negative and this particular charge is positive. If these two charges are separated by some distance, say L, and that length should be very small, that means that can be measured in nanometers or angstroms or micrometers. If that situation happens, we can call it as a electric dipole. So what is the definition of electric dipole is nothing but when the two similar charges magnitude wise should be same but opposite in nature. That particular two charges are separated by very small length distance, and then we can call it as a electric dipole. And here one more important point is electric dipole moment. So what is that? Electric dipole moment. So which is generally denoted by P bar. Now we'll see what is electric dipole moment. Same situation here, right? I have assumed here two charges, that is minus q and plus q, right? And let me take this particular point is O, so that which is exactly midpoint for the two charges. And imagine I have a length L from this particular charge to this midpoint, so that this is also L because these two are equispaced, right? And what dipole moment is telling us is, so my dipole moment will be equals to here charge into length between the two charges, that is charge magnitude of the charge is q and length between the two charges is 2L, because here it is L and here also L, together will be 2L. This product will be gives you what? Dipole moment, that is electric dipole moment. So electric dipole moment is a vector quantity. So this is a vector quantity. If we discuss about its units, and this charge is measured in coulombs, that is C, and my length is measured in meters. So coulomb meter is the SI unit of dipole moment. So in this particular session we would like to discuss about finding intensity due to this particular dipole. Okay, my aim is to calculate intensity due to this particular dipole. So now we'll see that. So what is my aim? To find out intensity, that is electric field intensity due to dipole. So to calculate electric field intensity due to dipole, this is further classified into three types. First one is on the axial line. If I take one charge on the axial line, how the intensity will be due to the dipole, and if I take the perpendicular bisector, how the electric field intensity will be, and anywhere in the space how the situation will be, we'll see. So to find out intensity due to the dipole, the very first case is on the axial line. What is that? On the axial line. Right. Now we'll discuss this and further we'll go for another one. So let me consider the system now here. This is my minus charge and this is my positive charge. I already told you for the dipole the two charges should be magnitude wise same and should be nature wise different, and these two charges are separated from the midpoint O, so that this length and this length should be same. So the dipole moment will be what? My dipole moment will be P equals to Q into 2L. Just now I thought, right? Now my aim is to calculate what? On the axial line, what will be the electric field intensity. That's my aim, right? For that I am assuming point P here somewhere. This is the point P where I am supposed to calculate the intensity. So wherever we wanted to calculate the intensity, that is the place where we have to take a test charge. What we have to take? A test charge we have to consider. Say my test charge is Q naught. What is this test charge? Q naught. A test charge is always a positive charge. Now we have to find out intensity due to this particular charge and also due to this particular charge. Let me consider this charge value is 1 and this charge value is 2. Okay. This is 1 and this is my 2. Now I am supposed to calculate what? Intensity due to the first charge as well as intensity due to second charge at the point P. So for example, let me consider my P is at a distance x from the midpoint. Got this point? Once again I am repeating. My P is at a distance x from the midpoint. So that what is situation here is, we know that intensity formula what? Generally E bar equals to KQ by R square. This is the formula of intensity, KQ by R square. So now we have to calculate the R value, corresponding R value. So for example, say this is my negative charge. What is this? Negative charge. This negative charge is going to act on the test charge P at this particular point. So as this is a negative charge, so as this is a positive charge, what happens? There is a attraction takes place. So that due to that reason, there is a intensity acting in this direction that I am taking as E1. Why intensity is acting in this direction? Because this is a negatively charged body and this is a positive charge, so that attraction takes place. This I am taking as E1. So now my intention is to calculate what? In how much distance it is displaced, it is placed. You already know this is x and this is L, so the total length will be what? X plus L. So my total length will be from here to here, this is x plus L up to this particular point. Similarly, we need to calculate what? Due to the positive charge, we need to find out the intensity at this particular point. So if I calculate it, so this is a second charge, positive charge, right? And this is also positive charge. Then what happens? Repulsion takes place, that I am taking as E2. And also I supposed to calculate distance between them. And the total distance from here to here is x, I assumed. So that this length will be what? And this part is L and this length will be my x minus L. Clear? This is up to here. Now I found out R values, corresponding R values. For negative Q to this particular point is x plus L, and from positive Q to this particular point is x minus L, and we have to find out E net value. So to find out E net value, whose intensity is greater, we have to find out. So for that reason, for that case, I am using this particular formula. Say if R value is greater, so what is my E value? E value should be very less, right? And if R value is lesser, then my E value will be greater, right? As the distance is increasing, intensity value is what? Decreases, and vice versa. Now you can see here x plus L is the total distance, whereas x minus L is the total distance between the two charges. Now in this case, which distance is less? This is the distance we have less case. So in that case, this gives the intensity of E2, whereas this particular distance gives the intensity E1. So in these two cases, my second intensity is greater than the first intensity. So on that reason, my E net will be equals to E2 minus E1. Why I have to subtract from E2 to E1? Since E2 is greater than E1. Because of the reason is E2 is greater than E1. So you know E2 formula, intensity formula, just substitute, you know R value, and my E net becomes what here? This is KQ, because I have assumed a charge Q by R square. R square means for the E2 R value is this much, that is x minus L whole square, and minus what is the E1 value? That is again KQ by x plus L whole square, right? This is the value, and further simplification we can take the KQ common, and the remaining is, this is a plus b whole square, a minus b whole square, this is like a plus b whole square. We can write a square minus b square whole square, that is x square minus L square whole square. If I do so, and the LCM becomes what? X plus L whole square and minus x minus L whole square, right? Okay, now we again on the simplification, what will be the answer? See here, again simplification, if I do, my E net value equals to KQ into, what is this value? X square plus L square plus 2LX minus, what about this value? X square plus L square minus 2LX by, what is the remaining down? X square minus L square whole square. Now you can see here, this X square L square, this X square L square gets cancelled, and finally, and it becomes what? 2LX plus 2LX will be 4LX by X square minus L square whole square, right? Now what I am doing here is, as I am supposed to calculate the dipole moment, let me convert this value like this. See here, that is, I am rewriting this equation as 2 into KQ into 2LX by X square minus L square whole square. So nothing I did, I just separated 4 as 2 into 2, okay, so that Q2L can be written as what? Because this value is my dipole moment, right? So I can rewrite this equation like this, 2kp, because this value is p, and remaining x by, and I already mentioned you in the beginning, my L value is very small when compared to x. So as x is greater, very greater when compared to L, so in front of the x my L value is very small, so that I am eliminating my L value, and which is going to be 0, and the remaining is x square whole square, and it becomes what? X power 4, and which gives you my E net. And now 1x cancel, and finally my E net value will be equals to 2kp by x cube. This is the E net value. Okay, I hope you got this particular derivation, and the next session will come to know and what is the electric field intensity due to the perpendicular bisector. Thank you so much.